Dear students, in this presentation we will discuss a problem on artificial neural network, that is on perception and learning theory. As you can see that in the diagram there is a node which is also called the place where summation function is implemented. This is that summation function which receives n number of inputs like x1, x2, x3, like that, xn. All these are the inputs which are given to the node. Okay, input from various neurons. Then in order to get the proper output, we need to give two informations. One is the weight, which starts with the initial weight, as and when you repeat it, we call that technically epoch. When you repeat it, the weight get updated. Weight may be decreasing or it may be increasing. You have to stop this process of repetition once the weight saturates. So that is the weight component. You can see for each input there is a weight component, W1, W2, W3, like that. Okay, here you can see. The third component is the collective summation of product of input and the weight is called net sim. The summation of weight and the input, sigma x w, I ranges from 1 to n, that is the net sum function. For the purpose of adjustment, for the purpose of updating the weights, we need activation function. There are different activation function which takes two inputs. One, this collective sum. The next is the threshold. Okay, it produces the output. The process we are going to stop if the desired output and the output obtained are same. Otherwise, we observe the error. Again, the process is repeated. So whenever there is an error, the same process has to be updated. For the next step, we are not going to keep the previous weight, but weight has to be updated. How much to be updated? That we'll see in the problem. Now, the output y is 1 if the sigma function of f of x is greater than or equal to theta, 0 if it is less than the theta value. That is the threshold value. The algorithm goes like this. For all the weights W1, W2, W3, like that, till Wn, you have to start with the initial weights. The bias value, that theta, has to be taken, which is a random number, which is in the range from minus 0.5 to plus 0.5. For each step, for each epoch, compute the weighted sum by multiplying the inputs with the weights and add the product, that is sigma xwi, where I ranges from 1 to n. In the next step, apply activation function on the weighted sum, that is x1 w1 plus x2 w2 minus theta. If the sum is above the threshold value, the output, the value as positive, otherwise the output is negative. The next step, after getting this output, we know from the table the desired output. From the desired output, subtract estimated output. That output we are getting from the formula, estimated output. subtract it from desired. If there is a difference, we can say that the output is not proper or erroneous output. That is error E of t equal to y desired minus y estimated. The next step is to update the weight. How much to be updated? That is the delta component, delta W, which is equal to learning rate. One more input is required here, learning rate into the error E of t and x. Repeat this process for all x. Then this delta has to be updated, delta has to be added, positive or negative, delta has to be added to the previous weight. The previous out weight getting updated, and the new weight is equal to previous weight plus that delta value. In this way, the process is repeated till there is no more weight changes. Let us take one example. We are going to test it on AND gate. You know the truth table of AND gate having two inputs. If both inputs are 0, the output is 0. Both inputs are 1, output is 1. If one of the input is 0, other is 1, the answer is 0. As this AND gate in this example take two inputs, W1 and W2, we'll start with the initial weight, that is W1 equal to 0.3 and W2 equal to 0.2. For this experiment, you can keep learning rate as alpha, that is 0.2, bias theta equal to 0.5. So we'll be using step function as an activation function, which gives output value binary 0 or 1. If the value of f of x is greater than or equal to 0, the output is 1, otherwise it is 0. Design perception that perform Boolean AND operation and update weights until the Boolean function gives desired output. This is how the same AND gate node is represented. The input can be 0 or 1 for x1 and x2. Initial weight is set, W1 equal to 0.3 and W2 equal to minus 0.2. We will be computing the step function sigma x into W. Compare that with the output, otherwise feed to the initial stage. Here theta is assumed as 0.4. This is a truth table of AND gate. When one of the input is 0, output is 0. Otherwise, if both inputs are 1, output is 1. Let us take this in each steps epoch value, that is 1. In the first case, 0 x input and 0 x2 output input, that produces as per the table 0 into 0 is 0. We'll see what this node gives in each step. 0, this is x1, weight W1 plus x2, W2 weight. 0 into anything is 0, 0 minus 0.4 is minus 0.4. As we have mentioned, if it is less than that, if it is less than 0, then output is 0, otherwise it is 1. Estimated output is 0, the desired output is 0, both are same, 0 minus 0, there is no error at all. Then, as there is no change, we can keep previous weight, what we have assumed, W1 0.3, W2 minus 0.2, no change in the things. This weight is taken in the next step. In the next step, x is 0, x2 is 1, W1 is 0.3, W2 is minus 0.2, subtract it from 0.4, that is theta. The value is less than 0, so we are assuming that is 0. Then no changes in W1 and W2. W1 is 0.3, W2 is minus 0.2. Substitute this in the next step. 1 into 0.3 plus 0 into minus 0.2. 0.3 minus 0.2 is 0.1. 0.1 minus 0.5, which is less than 0. So answer is 0. There is no error. What we have assumed, what we obtained, both are same. We can keep the same weight for the next. In the next step, 1 into 0.3, 1 into 0.2, altogether 0.1 minus 0.4, again 0 minus 0.4, the answer is 0. There is a difference in the output. 1 minus 0 is 1. Okay. Now, as there is a change, you have to compute learning rate delta into E of t into x1. Learning rate is 0.2, E of t is 1, and x is also 1. 1 into 0.2 is 0.2. For this you have to add W1. We computed delta W1, add this to W1. W1 plus delta W1, that is 0.3 plus 0.2, altogether 0.4. Now we will go for delta W2. Delta W2 equal to learning rate alpha into E of t into xt. Learning rate 0.2 changes, not changing, into error 1 into x2 1. 0.2 into 1 into 1 is 0.2 is the delta value. Add this to the previous one. Minus 0.2 plus delta 2 is equal to minus 0.2 plus 2 is 0. So we have completed the first epoch. We'll go for the next one. The previous weight what we got is 0.5 and 0. That we are going to take here. If there is no error, same is propagated in the next stage. Here, in the third case we saw there is 1 and the desired is 0. 0 minus 1 is minus 1. There is a change. W is computed as delta W is computed as alpha into E of t into xt. 0.2 into minus 1 into 1, that is minus 0.2. Add that to W. 0.5 plus delta W1 equal to 0.3. Similarly compute the delta for W2. Learning rate into error of t into x2, that is 0.2 into minus 1 into 0, that is 0. W2 equal to W2 plus delta W2, 0 plus delta W2. 0 plus 0 is 0. Try for input 1, 1. Weights are updated as follows. Delta W1 equal to learning rate into E of t into x1. In that case 1, 1, case 1, 1, 0.5 weights are updated. Delta W1 compute alpha into E of t into x1, alpha 0.2, E of t, there is error, into x value is 1, altogether 0.2. Add this to 0.3, that is 0.5. Similarly compute delta W2 equal to alpha into E of t into x1, that is 0.2 into 1 into 1, 0.2. Compute W1 by adding this delta W1. The same we repeat it for W2. So that value will come here. Like this you proceed. So in one fine time, in all these cases, no changes is observed, and this is treated as the final answer. XOR problem, this is unsolved. Solve it in the same way. XOR truth table says when inputs are different, 0, 1 and 1, 0, the output value will be 1. If inputs are same like 0, 0 or 1, 1, value is 0. Try this.